We've spent a little bit of time talking about how to name straight chain alkanes, but we can also have alkanes in a ring or cyclic configuration. And when that's the case, we simply add cyclo as a prefix to the alkane, the number of alkane. So here we have a 3-carbon ring, so that would be propane, and then since it's in a ring, we say cyclopropane. Same thing for our cyclobutane, cyclopentane, and cyclohexane. Now, this is the case if we have the ring being the most prominent feature of the molecule. However, if this is a substituent, then we simply change it to the ane to a YL, and then it becomes cyclopropyl, cyclobutyl, cyclopenyl, cyclohexyl. Let's do some examples, and I can show you what I mean. So in this first case, we have a cyclohexane. There's a 6-membered ring, and there's 2 carbons off of the ring. Now, since every position on this ring is the same, and there's only one substituent on the ring, we do not need to have a locator number. So instead, we can just say ethyl cyclohexane. Now, if there's more substituents on the ring, we'll have to number them. So we'll get to that in a second. Now, if we look over here, we have a cyclobutane, but the chain on it coming off of the ring is 5 carbons long. 5 carbons for the chain is more than the number of carbons in the ring. Therefore, this is the parent molecule, and this is now a substituent. So this is on the first carbon, right? Because we are going to try to lower the number that we say, and we would say on the first carbon 1, and then this is a cyclobutyl group, so and this is a pentane, so 1 cyclobutyl pentane. That happens when the ring is smaller than the chain. All right. Now let's look at what happens when we have multiple substituents around on the ring. So here we have different carbons, right? We have 1 carbon that has a chlorine and a methyl on it, and then we have another carbon that just has a methyl on it. Now, since we want the lowest number possible for substituents, we always choose the number 1 carbon to be the one that would have 2 substituents on it if we have that. If this was not the case, we only had 1 here, then it would go by alphabetical order. And let's assume that maybe there wasn't this methyl group there. This would still be the number 1 carbon just because chloro is before methyl. But there's 2 substituents, so no problem. So we're going to say 1 chloro. There's 2 methyl groups. There's 1 on the 1 carbon, and then we want to count around the ring in the direction that the second group has the lowest number. So if we were to count 1, 2, that's going to be the lowest, because if we tried to go 1, 2, 3, 4, 5, that would be way higher. So this is 1,2-dimethyl cyclo and then pentane. All right. Now I have another molecule down here. This one's a cyclohexane. And we have two substituents right here. So on this first carbon. So this must be carbon number 1. And then we have a choice. We can count this way or we can count that way. So let's try counting 1, 2, 3, 4, 5, 6. Well, that means that our bromines are on the 3 and the 6 carbon. Instead, if we count 1, 2, 3, 4, 5, those are lower. So that's the way to go. 1, 2, 3, 4, 5, 6. Nothing on the 6th carbon. So let's start naming this. Alphabetical order says that the bromine should be first. So this is 2,5 dibromo, 1,1 dimethyl, and then cyclohexane. So that's just a little bit about how to name cyclic alkanes, either when it is its own parent molecule, it's the longest chain, or when it is not and it's a substituent. And we'll see you in the next video.